All right, 2015 problem number 5 about the arm span versus the height of a person. So this first one did ask for the correlation, and so you had to put those components in there about there is a strong, there is a weak, positive or negative linear correlation between X and Y. Okay, so in this case, I put moderately strong because it wasn't, real tightly clustered together. So moderately strong, it is positive linear relationship between the height and arm span. And I went ahead and included the units. All right. So for credit on that one, you had to include the relationship is approximately linear. The relationship is positive, moderately strong, and context. All right. So you had to include all 4 of those for full credit. Um, it the correlation alone is not sufficient to indicate linear. However, linear correlation is sufficient. If you said a linear correlation, then that indicates that linear relationship. So you got that credit on that. Putting the correlation as 0.81 or that it's close to 1, that kind of value and ranges of the value for the correlation coefficient is not sufficient to get that correlation component or that strength of the relationship. All right, next part. Here you had to really understand what was going on with this line here. So you had to understand that this graph on the left is the least squares regression line. So the one that best fit the data. But here on this graph number 2, we had the line y equals x. So the reason that that's important, y equals x, is because of the definitions on the next page. Because the definition being square is that the arm span is equal to the height. So then that means that I can best tell what's going on with this line y equals x, because that would be the height equaling, or y, the arm span equaling the height, which is the x. So then in that case, I could see that I had 3 people who were considered, quote unquote, square because they were on this line y equals x. And then the definition on the next page that the arm span, so that's the y, is less than the x. So over here, again, by looking at this, if the arm span is, so this y value is less than the x value, that's all of these 4 people that are down here on the bottom. So this is the people that are considered tall rectangle. And then by definition here, the arm span is greater than the height. So that would be these people over here. Let's see. So this y value is greater than the x. So that would be these 5 people who had that are short rectangle, arm is greater than height. So in all of these cases, the line that was most helpful in determining this was the y equals x. Because, so I chose graph 2 as the answer for this one, because on the y, any point data on the y equals x is the arm span equaling the height. Above is the arm span greater than the height, and below is the arm span less than the height. So to get full credit on this problem, on that one, you had to indicate graph of line 2. So if you didn't do that, you're out. And so then you had to have a reasonable explanation. You did not have to include all 3, but you had to include 2 of those statements I made about how any data that is on the line is considered a square shape because the arm span is equal to the height, and then that the ones above the tall rectangles were the ones less than the height, so that was below the line. Okay, and then another option was the short rectangle was the ones greater, so they were above the line. So you had to include 2 of those 3 relationships to get this component 2. So component 1 is stating that graph 2 is needed, then spelling out the explanation of the relationships between arm span and height. Then you had to do a correct count. So you had to do the 3 and then the 5, or 3, 4, and then 5 on that table, because 3 were on it, 4 were below it, and 5 were above it, and that you had those correctly written down there in the table. You want to read some of these ones here as to how you could have gotten some partial credit. Interestingly enough, if you they considered it a minor error if you only noticed 2 of the dots that were actually on the line. So if you did 2, 4, 5, then you were good and you got credit. If you had interchanged the 2 sections and put 2, 5, 4 or the 3, 5, 4, then let's see, you get component 3, but not component 4. So that would have knocked you down to a partially correct. So you had to have all 4 of those correct for an E, and 2 or 3 of them correct for a P. So just 1 correct did not give you enough credit. So you got it for 2 or 3. So that's nice. All right. And so then the last one here was to just predict using the best model for the prediction. So that, of course, then would be this line of best fit. Predicting the arm span, so the predicted arm span for a height of 61 inches. So that's a value of 61 being plugged in for the X. I want to point out to you that you actually had to have units on this to get full credit. So let's take a look. So here on the grading guidelines, look at what was required for Part C. You had to have the correct formula for the predicting the arm span with 61 inserted for the X, correct value for that predicted value. But look at number 3, units for the predicted arm span was given as inches. If you did not put the units, then you got marked down to a P from an E. So big deal on that little detail there. Okay. All right. So of course, here are your things here. EEE for a 4, EEP for a 3. Here's all the 4 ways that you can get a 2, quite a few: EEI, EPP, EPI, PPP. And then, of course, just one E or 2 Ps for a 1, which is considered minimal. All right, so that is your 2015 problem number 5 explained in the grading guidelines.